Hello, this video is about the handbrake I made. This video is going to be a bit shorter than the others. I will go over the design process, how it's built, and then how it's connected to the Arduino that I'm using to control all of my gears so far. This is part 4 of an engineering project I've been doing to build a sim rig from scratch and use it to win the My Summer Car Rally. The first 3 videos were about the pedals, rig, and the shifter. You can check out these videos in the description below. I do have something important to share. If you don't watch a second more of this video, please know that I have updated the Arduino code that was used in the previous shifter video to be able to work with all games, not just My Summer Car. I will get into it more later, but you can find the updated code at my GitHub linked in the description. Alright, let's get into it. Here's a quick disclaimer. I went down a lot of dead ends in the design for this, and I'll briefly mention the missteps I took. To start, I used a standard handbrake concept like you might see in an everyday road car. I made a diagram of the important pieces of this concept. The first important piece is this orange piece that is fixed. This is what provides the point of rotation and the ratchet effect to the handbrake. The next are the two pieces that make up the handle. They both rotate similarly about the central hole on the orange piece, and there's a spring inside. So right now in this current configuration, the handbrake can only be rotated to the right, and that is with some resistance. But if we press this green button here with our thumb, that compresses the red spring and releases the key end of the green piece from the orange teeth to rotate freely. So I started modeling this up, but it became pretty obvious that something was missing, and that is a force to return to the neutral position. To be honest, I kind of struggled with finding the appropriate method to provide force. I couldn't find any great torsion springs online, and I wasn't sure how best to convert rotational movement to a linear spring. One idea I came up with was to use a gear track so that when the handbrake rotates, it pushes a lower platform and compresses a linear spring, but I abandoned this idea because there was too much sliding of 3D printed parts. So I completely started over and began playing with some vertical handbrakes instead, and pretty soon I settled on a design. What I came up with is to use links to mirror the motion further away from the handle in order to free up design space. Note that the orange wheel is a gear. From here, I could add a gear for a potentiometer so we can detect movement and a frame to keep everything together. I added pegs on both the orange gear and the blue frame to attach rubber bands to in order to provide a return force. Once again, I went back to model it up and I think it came out really well. I was very happy with the looks of this design, although I was a bit concerned about the non-symmetrical nature of the connections. Anyways, good enough to print. Alright, so after some quick prints, we're ready to assemble. The first thing we want to do is insert the bearings. These are just standard skateboard bearings and should be a nice press fit. I think I might go back eventually and use some super glue here as well, but for now they fit snugly enough. There are 3 bearings to install in the wheel gear and 3 in the handle. Next, we similarly want to fit the 5/16-24 nuts into the press fits on the links and the back of the frame. Then we can install the links onto the gear wheel and then onto the handle and attach both of those to the frame. Everything should feel pretty smooth and solid. If not, I would definitely suggest using some super glue. I didn't use any lubricant on this design, there's just no reason to. The gears move well enough on their own, and the bearings are the only other places of contact between parts. The next thing is to install the potentiometer. I recommend using a socket head for this, otherwise it is quite hard to tighten that thin nut. Then we can install the small gear on the potentiometer. This is just a press fit, so pretty easy. The final thing to do is to add a couple rubber bands and the design is complete. Funny story, I printed in pink because I was assuming I was going to have to make a V2 or 3 for this design, and I didn't want to waste any of the cool colors for the final design, but it actually turned out really well, so I don't think I need a V2 or 3. That's why the entire thing's pink. I swear I have more style than that, but anyways, the pink is kind of growing on me, so it stays. The electrics here are super simple. I use the same potentiometer and circuit as I did for the pedals, and I use the A7 analog pin on the micro to read voltages. One problem with the code I presented in the shifter video is that some games like Dirt Rally 2.0 won't pick up on the inputs if you are using both the keyboard and the joystick libraries. So although it worked in my summer car, it's best to only use one library and one controller for the games. So first I'm going to go through what changed from last time, and then I'll go through what's new for the Handbrake. So the first change is just no longer import the keyboard library. The second is we want our state and last variables to be integers and not characters like last time. And then when we create our joystick, we want to make sure to provide an argument here for 8. This 8 means how many buttons should be included. So this is all of our gears and then reverse as well. So scrolling down here, we find where we assign the state variable, and we want all of these to be integers as well. One difference is that it counts first gear as 0, so the first button is actually considered an integer of 0, so we just have to adjust by 1, and then set reverse to something within our range of 8, which happens to be 7, is our final value. And then 11 for the kill val, because we're not actually going to be setting that state. And then next here, instead of doing a keyboard release and press, we're going to be doing a joystick release button and joystick press button. And that's all that's changed for fixing communication with games like Dirt Rally. The new code for the Handbrake is as follows. We've got defining our A7 pin, and then down here we're going to add another axis for our Handbrake. And we're going to add a new block of code in the same way we did for our pedals for the Handbrake here. And it's as simple as that. So once you have everything set up, one easy way to check functionality is to go to your control panel and then find devices and printers. From there, you can view the properties of your Arduino and visually confirm it's working properly. And here we're going to pull the Handbrake, and you can see that the input's working right. This is a lot easier than going into the game input menus and trying to troubleshoot there. So if anything goes wrong or you're just curious, I highly recommend you check out this menu. I hope that this video was entertaining, or that you were able to learn something or get inspired somehow. Thank you to everyone who has been watching these videos. I'm having a lot of fun doing this, and I really appreciate the engagement I've gotten. Originally, I didn't know how far I was going to come doing this, and I still don't. It's a ton of work, but I'm really enjoying it, and some of the nice comments I've got have really inspired me, and they do mean a lot. As always, if you have any questions, comments, suggestions, or requests, feel free to reach out. I usually get the messages fairly quickly, and I will try my best to read every comment. Also, please leave a like and sub if you are enjoying these videos. Just a reminder, you can find all of the STL files on Thingiverse for this project, and also the code on my GitHub. Both are linked in the description down below. If you haven't checked out the other designs in this series, please do so on my channel or on my Thingiverse page. I'm not sure what's going to be next. I've been feeling tempted to make a sequential shifter in a similar style to the Handbrake, but I also have a completely different project I'd like to share, maybe before I get to the wheel, so keep an eye out for that. That's it for me. Thank you for watching. Have a nice day.